Hello, this is Andrew. In previous videos, we've discussed why do you need a switch. We looked at things like collision domains, CSMA, CD, and now we're going to look at why do you need a switch and actually put that in a network and see what it does, okay? So let's take a look at our model. We have in this set of videos been looking at what happens when a PC in Seattle transmits to a PC in New York City. Okay, so we've actually been looking at what goes on at the OSI layers in the PC and the server, and somewhat over the network, very little so far, but there's also something going on behind here. We actually have a business with 3 floors in this building. Let's say floor 2, floor 3, and floor 4. And on these floors, we have 20 employees each. And this PC is one of those PCs. And he's wanting to send data across here. Well, something's happening in the building first before it's sending out over the network. So let's take a look at what's actually going on inside this building. Okay, this is some example of a LAN using hubs. Okay. A local area LAN is just that. It's local and it's generally a small broadcast domain, faster, maybe cheaper, just to send it to everyone than to actually do routing. So what exactly does that mean? Well, you have to think first. So it's hard to present this material in some ways because now they have layer 3 switches that actually do routing, but the CCNA doesn't cover that. So the material I present to you is the way you're supposed to see it for the CCNA, which later you may understand that it's actually more advanced. But for now, this is what Cisco wants you to understand. Okay, so also you got to think that the design and architecture of networks is still influenced by the history of the technology, and I'll show you what that means. So for example, we have 20 employees on floor 2, 20 employees on floor 3, and 20 employees on floor 4. We're only going to look at the first 2, but we're aware that there's 18 more out here. All right, this guy is MAC address of all A's. He's a MAC address of all B's, MAC address of C's, D's, E's. You get the idea. All right, so this switch is on floor 2, 3, 4, as we said. Now, this is hub, so when I transmit a message out of A, B gets it, C gets it, D gets it, E gets it, F gets it. Everybody in that broadcast domain gets the message. It also goes up here to this router, but this router blocks it. Okay, the router says, this could be the internet over here. You could have literally billions of IP addresses over here. You don't want to flood this to a billion people and then have a billion other people flooding everything to you. It would just be a nightmare. So the router actually uses, a much more intelligent planning and switching type process to actually route data. But the downside is that, at least initially, is routers cost more and it took some processing time. It was slower. So for inside here in this local area network, we could just put a hub in and, of course, when A transmits and B transmits at the same time, you get a collision. We know that. And it does the CSMA CD, where it has to back off and wait a random amount of time before it transmits again. So you can see that at some point, if this broadcast domain is too big, all that collisions and back off times is really going to slow down the network. But for small networks, it worked out and it was okay. But, as technology marches on, things get better, we came up with the switches, and I discussed the switches with you earlier. So the switch is basically, initially it's like a hub from our standpoint while it's building the MAC tables. So A wants to go to F. The MAC address of A wants to go to MAC address of F. This switch looks at the source address of this incoming message and says, oh great, your MAC address A. You're on this port right here. I'm going to put that to my MAC table. And then on it continues the process. But what happens is he floods it out everywhere. He floods it here, here. This switch does the same thing, floods. We've been through this process, floods everywhere. So everyone in the broadcast domain gets the message initially while it's building the MAC tables. Okay, once the MAC table is built, though, we see a situation like this. MAC address A wants to send a message to MAC address E, and all three of these machines have their MAC address tables built. So he just simply goes directly over to E. And the same thing could happen. F could send directly to D. Okay, that's great, but you may ask the question, and I know this was the question I had when I was learning this material, is if MAC address A is transmitting directly to MAC address E, how is this one big broadcast domain? That's what this blue bubble is indicating, one big broadcast domain, at least on this slide. Okay, so, well, the key about a broadcast domain is he could send it to everyone in the broadcast domain. So A could send a message to B, A could send a message to C, and A could send a message to D. And you get the idea. All of them can send messages to each other. That's what makes this a broadcast domain. They all can send messages to each other, but they don't have to. They can use the MAC table to speed up the process such that they don't have to flood data out every port and, waste bandwidth and cause problems. So from that example, you can see that the switches are really good. They've really improved over the years, and they've isolated this LAN from something else out here. But at the same time, they allow messages to go directly between each other without completely flooding the entire LAN. Okay. All right. So with that, I'm going to stop the video and pick it up on the next one. Thank you.